Hey guys, today's video is going to be basically an introduction to the Sustainable Earth Project. And throughout this video, I'm hoping to introduce you to each of the aspects of sustainability that you'll be researching throughout the course of this project. Let's go ahead and get started. Now, there are four essential questions that we're going to be talking about throughout this video. Number one, how do scientists believe that the Earth was formed? And that's a really key question in big history, but it's also going to help us understand how that relates to uh, the sustainability that we're hopefully going to get to with our Earth's resources. Second, what makes Earth different from other planets in our solar system? Obviously, Earth is very different than a lot of other planets in our solar system for a variety of reasons. So we'll talk about that through this video. Number three, how did the formation of the Earth lead to the distribution of resources? And number four, what impact does plate tectonics have on the current distribution of our resources? So in other words, all four of these questions are getting to the idea that the formation of the Earth has in some way influenced where resources are and are not in our current version of the Earth. Let's start with the formation of the Earth in the solar system. Our story really starts with the formation of our sun about 5 billion years ago. Now, the sun, very similar to other stars in our solar system, formed through a process of nuclear fusion. And if you remember back to the process that we talked about with the formation of stars, we eventually had the collapse of a nebula. And through this process of nuclear fusion, that's illustrated here on the left, the sun was formed. And the sun is really the key component of all of our story here on Earth. Now, the planets in our solar system formed shortly after the formation of our Earth, about 4.5 billion years ago. Now, about 4.5 billion years ago, we have something called an accretion disk. An accretion disk is leftover material that's held in orbit around the sun by gravity. So when the sun was formed, there was a bunch of leftover material kind of circling around the sun that was held there by the sun's gravitational pull. Eventually, that material comes together to form larger planets. And we call this process accretion. And this is a really significant term to understand. Accretion occurs when smaller particles collide and stick together to form larger things. Think of it like Play-Doh, for example, right? Like if you had a whole bunch of Play-Doh as a kid and it's all sitting in different places, and you take one small piece of Play-Doh and you begin to stick it on other pieces of Play-Doh, eventually that Play-Doh sticks together to form one larger piece of Play-Doh, and that's kind of how the sun is formed, or not the sun, excuse me, the Earth and other planets in the solar system are formed. Now, a planet. Just to give you an idea of the definition of a planet is a body that orbits the sun with gravity strong enough to make it spherical and has cleared the area of smaller objects. Uh, Planets typically have their own gravitational pull, which is when you have moons circling around those planets. And if you look on here on the bottom left, these are the planets that we currently have in our solar system. You'll notice that Pluto is missing, and Pluto is kind of a controversial one, as you may have seen. Like it goes in, it's a planet one day, it's not a planet the next day. It's interesting, and we'll talk more about Pluto later. There are two types of planets I'd like you to be aware of. The first type of planet is called a rocky planet. And a rocky planet is a result of what we call stellar winds. The sun, if you look at this picture here on the left, pushes out very strong and hot winds. And those winds blow the gases away from these rocky planets into the areas of the gas giants. And so if you look, the first four planets in our solar system, Mercury, Venus, Earth, and Mars, are what we call the rocky planets because their gases were blown away by those solar winds. The gas giants are the ones that aren't touched by those winds, right? So Jupiter, Saturn, Uranus, and Neptune are what we call the gas giants because the stellar winds from the sun have not gotten to those places. So those are two types of planets that you should be aware of. The Earth, as one of the first four planets, is a rocky planet. Now let's look specifically into what the Earth looks like. About 4.5 billion years ago, when the Earth was formed, it was uninhabitable for life in general. Now, had there been life on Earth, there would have been a few things that would have made it incredibly difficult. Number one, Earth was basically molten lava. So it was incredibly hot, and you would not have been able to really move around Earth at all. Second, there was no oxygen. Uh, Obviously, a lot of life forms, including humans, depend on oxygen to survive. And without oxygen, we would not be able to breathe. So Earth is hot, it's full of lava, and there's no oxygen at all. Third, even if you were fortunate enough to live despite the molten lava and the lack of oxygen, you would be constantly dodging asteroids and meteor strikes. The early Earth is kind of like a war zone. We have all these uh, celestial bodies like kind of hitting Earth, and it's just really uh, not a peaceful time to be living on the planet. And then fourth, you would have high levels of radiation. The heat and the materials that are making up the early Earth give off a high level of radiation, and because of that high level of radiation, even if you were fortunate enough to be alive, you wouldn't have any of your hair, and you probably wouldn't live very long. Now, about 10 million years after the formation of the solar system, we really start to see the formation of the Earth in terms of the layers that currently make it up. And the Earth begins to kind of melt into these layers. The heaviest materials, like nickel and iron, sink to the center of the Earth, and we call that the core. So the core is the heaviest part of the Earth because it has the heaviest elements in it. Above that, you have the mantle, and you see this reddish area here is what we call the mantle. This is semi-molten, meaning that parts of it are solid and parts of it are more liquidy. So it's kind of like a mush of solid stuff and of liquid stuff, and it's kind of like this. Just think of it like a big area of like a rock soup, kind of. Sitting on that, you have what we call the crust. These are the lightest rocks that cool on top of the mantles. They kind of float to the top, and they cool, and they cover that mantle. The crust is where humans live, and in fact, some, especially in big history, we call this a surfboard. So if you think of like surfers with their surfboard surfing on the ocean in this case would be the mantle, and the crust would be the surfboard. So big history likes to say that humans are like lava surfers. We're all kind of surfing over this semi-molten area of the mantle. And then finally, above the crust, you have what we call the atmosphere, which are the gases that evaporate above the crust. If you need another visual of this, think about it if you like just threw a bunch of stuff into a pot and you started the heat on that pot. What would happen is that the heaviest things would be at the bottom because they are the heaviest, they would melt, and then the lightest things would be above it. And then, as you know, if you've ever made like mac and cheese or any kind of, something on the stove where you boil water, you have the gas that's above it. That would be kind of like our atmosphere. So it's, again, a very simple and basic explanation, but that's kind of what the Earth would look like. Now, one of the key parts here is something we call plate tectonics. Plate tectonics is really the fundamental idea of geology and of all Earth science. The main idea of plate tectonics is that Earth is divided into dozens of what we call plates. The crust, in other words, is subdivided. And if you look at this map here on the top left, these are what the plates look like. There are 7 large plates that coincide with the location of major continents. And so if you look here, you see North America, you see South America, Africa, Europe and Asia, and Australia, right? So, Antarctica, sorry. And those large plates, again, coincide with the continents. Others coincide with the oceans. So you see here like the Caribbean plate, you see the Pacific plate, right? So a lot of the locations of these plates coincide with the major things that we see on our globe right now. There are 2 types of crust that you should be aware of. The first is called continental, which is lighter, and the second is called oceanic, which is heavier. And when these types of crust interact with each other, there are a variety of things that occur. The first is that we see the formation of mountains. So if you think of 2 plates of crust coming together and kind of crumpling up on each other and kind of building on each other, that's kind of how mountains are formed. We also see in what we call slip faults, where you have 2 plates that are kind of like rubbing against each other. And the friction of those plates rubbing against each other causes earthquakes. And when those earthquakes happen in bodies of water, they form tsunamis. We also see the formation of volcanoes. In fact, part of our Earth, right over here, in fact, with the Pacific plate, we call the Ring of Fire. And the reason we call it the Ring of Fire is because there is a large amount of volcanic activity that occurs on these fault lines. And so all of those things happen when crusts come together. Now, the scientist that really started this whole idea of plate tectonics is a man named Alfred Wegener, who was a German meteorologist. Now, you might think to yourself, like, what would a meteorologist know about the structure of the Earth? And that's kind of how a lot of people looked at him when he had this theory. It's like, dude, you're a meteorologist. How could you possibly know how all of this works? But Wegener's theory basically was that at one point, all of the continents had at once been together into one full body, which we call Pangaea. And this picture right here at the bottom is what we believe Pangaea might have looked like. And even though Wegener had evidence that the continents were at one point probably together, he still couldn't explain how those continents moved. Now, here's the evidence that he produced. The first major piece of evidence is fossil evidence. And if you look at the picture here on the top right, well, I guess the pictures are on the right side, but the top left picture on the right side, you see that on matching coastlines of different continents, you see very similar fossils, which would suggest that at one point, those continents were together, those species were living kind of around that area, and then when those continents moved apart, you started to see fossil evidence in both coastlines. So fossil evidence is a really significant piece of the plate tectonics theory. The second one, and we kind of hinted at it already, is the coastline matching idea. For example, if you look at South America and Africa, they look like they would kind of fit together. Now, obviously, it's not a perfect match because of erosion and that type of thing. But you can see when you put them side by side that it looks like they would have fit together kind of like a puzzle. The third and probably most interesting piece of evidence for plate tectonics is the age of the sea floor. So if you look at the picture here on the bottom right, you see that there are different colors here that correspond to the age of the Earth. And the theory basically says that at these fault lines, these cracks right here in the Earth's crust, there's lava being pushed up through those fault lines, and that lava is pushing the plates apart. And to illustrate that, the areas that are red here are the youngest ages of the seafloor. So the areas around the fault lines is where this new lava is being pushed up. And then as you move further and further away from the fault lines, you see that the seafloor is older, which suggests that the seafloor is pushing apart. Okay, so again, the youngest seafloor is located where the plates meet. The oldest seafloor is located further from fault lines. So all of this, these three pieces of evidence really support that plate tectonics is how the Earth kind of functions. Now, this plate tectonics has pretty significant impacts on geology and resource distribution. For example, many natural resources are located near past or present plate boundaries. Not only precious metals, as you can see here, but also things like fertile soil. Areas around volcanoes typically have the most fertile soil because the ash and the things that are ejected from a volcano typically create the most fertile farmland. Now, when we talk about Rome later on, you'll notice that sometimes can have negative consequences, but for the most part, that ash that's created from volcanic activity creates very fertile farmland, which is a result of the breakdown of volcanic rock. You also see areas of minerals or deposits of minerals in areas above volcanic subduction zones and around magma-feeding volcanoes. In other words, the elements that make up the middle part of the Earth are brought to Earth's surface through volcanic eruptions. And eventually, because of erosion, those minerals then become exposed and people begin mining them, things like gold and silver and copper and stuff like that. Now, for the modern Earth, one of the most significant resources that we have is fossil fuels. Fossil fuels there are three of them that you should be aware of: coal, oil, and natural gas. And these deposits are found near mountain ranges where heat and pressure transform organic material. The reason they're called fossil fuels is because in these areas you had um, ancient life forms, right? So, for example, in the Middle East, you had what a lot of scientists believe was this ancient ocean and a lot of these different life forms. And eventually, those different life forms began to die and decompose. And that decomposed organic material is where, combined with heat and pressure, we start to get our deposits of coal, oil, and natural gas. So areas near these mountain ranges typically have the highest deposits of fossil fuels because of that very reason. These decomposed organic materials are using heat and pressure to create coal, oil, and natural gas. Finally, we have geothermal energy, which is areas near volcanoes that harness steam and geothermal fluids to power machinery and may also contain precious materials. But again, volcanoes are located near fault lines. And so near these areas of fault lines, you have the highest deposits of geothermal energy that we eventually use to power machinery and other things. Finally, water distribution. As we know, water is probably the most crucial resource that we have on Earth, and humans literally cannot survive without water. So first, let's talk about the difference between fresh water and salt water. Rain falls on Earth, excuse me, as fresh water. So if you've ever gone outside and tried to like catch raindrops and stuff, you'll notice that it's fresh water. It's not salty. It becomes salty because it picks up materials as it heads from the rivers into the oceans. There are deposits of these minerals, again, oftentimes near fault lines, where as the water moves on, it picks up those minerals and continues to carry them down. And it deposits those materials into what we now call oceans, which are salt water. It's kind of one of those um, parts of Earth that's kind of cruel, where you have a huge amount of Earth's surface covered by water, but a very small amount of it is actually able to be consumed by humans. Now, as water evaporates, because of the sun, right? The sun heats up water and evaporates. That water eventually falls as fresh water rain back into lakes and rivers, which is how lakes and rivers continue to replenish their water supply. Oceans remain saltwater because of the deposits from rivers and because of their own salt content. Right. So again, as those rivers continue to move down um, and pick up the sediment, and things like that, it stays saltwater. So, for example, the Mississippi, uh, it starts here and it begins to flow down into the Gulf of Mexico. A large amount of the fresh water that we have on Earth comes from ice, snow, and glaciers. Water in glaciers and ice caps represents a large amount of Earth's freshwater supply. In fact, about 70% of Earth's fresh water comes from glaciers and ice caps, which is why so many people are concerned that the ice caps are melting. Um, Lakes specifically form as a result of melting of glaciers over basins, which are created by those moving glaciers and tectonic plates. So you have these large glaciers sitting on these plates. The plates are moving over the mantle on the Earth's crust. And as they move, they are literally carving out pieces of the Earth's surface. And as they carve those parts of the Earth out, the glacier that's moving over them begins to melt and it fills in the basin that they created with fresh water. So, for example, the Great Lakes, which are incredibly important, especially in our area, were the result of these moving glaciers. Other areas of the world obviously have glaciers as well, and that's where we start to see the biggest lakes form. 21% of the world's freshwater supply come from the Great Lakes. So again, we are very fortunate, especially living in Illinois, that we have this large body of fresh water that allows this to happen. The other major piece of freshwater supply in the earth comes from rivers. Rivers also are formed from melting glaciers, but also from melting snow on mountaintops. And this is really gravity, right? So if you have water melting at the top of these glaciers, moving down the glaciers, very similar to a moving glacier, these streams of water are literally cutting paths into the Earth's surface, eventually creating rivers. So from the Great Lakes here, and some of the areas that are up here in Canada and the northern US, you start to see rivers carving their way down through the mainland of the US and eventually emptying into the Gulf of Mexico and into other bodies of water. Now, the last part of fresh water that we have comes from groundwater, which is water that's trapped in rock beneath the Earth's crust. And there are some places in Earth that have large deposits of groundwater that they can tap into to use. Now, if you look at the map here on the bottom left, you'll notice that there are some parts of the world that have more freshwater resources than others. The US, South America, Russia, and Australia, for example, have a pretty good amount of fresh water per person. And water conservation, though it's important, is not as crucial as in parts of the world, say in like the Middle East and in Africa, right? The population of these areas is also higher, which definitely plays a role in that. But again, the United States is very fortunate compared to other parts of the world because we have large deposits of fresh water. All right, to wrap up here, there are 4 questions you should be able to answer now that you've watched this video. Number 1, how do scientists believe that the Earth was formed? Number 2, what makes Earth different from other planets in the solar system? Number 3, how did the formation of the Earth lead to the distribution of resources? And number 4, what impact does plate tectonics have on the current distribution of our resources? After you watch this video, if there's still questions that you have, please write them down, and we'll try to talk about them as a class when we're all together again. Otherwise, please use this information to get kind of a general idea of how the formation of the Earth and how it functions impacts your aspect of sustainability. Thank you for your attention, and I will see you guys later.